Okay guys, this is Honors Algebra 1. This is going to be the video key for last night's homework. Usually we go through the homework in class. I figure I'll do that here on video. I'm also going to post just the PDF answer key. If you'd rather just look at the answers, check your work, move on, that's fine. But if you want to see all the steps, this is the video for that. Alright, your homework was 1, 2, 5, 6, 7, and 9. 1, 2. Okay, I'm going to do a couple of the other ones as well. So if you're looking for a specific problem, I'm going to go in order. So if you only want to see number 9, just you'd skip to the end. If you want to see them all, feel free to watch with me as I do this from my kitchen. Okay. All right. So this was factored form, graphing, and that's what the notes were on yesterday. So problem 1. They give you a factored form problem. Remember, we have certain values here. The A value is always going to be in front. A value is 2. The P value, remember in the formula, the P is X minus P. So we have plus 3. So that means our P value is actually negative 3. And our Q value is X minus Q. So our Q value is 1. Does this open up or does it open down? Well, remember, that always depends on the A value. The A value is positive, so this is going to open up. Which means that the vertex is automatically going to be a minimum. Okay, if your parabola opens up, that means the vertex is the lowest point, or the minimum. Alright, the X-intercepts are the P's and the Q's. So we have an X-intercept at negative 3. And we have another X-intercept at positive 1. Now the axis of symmetry is going to be halfway between those two X-intercepts. So the formula we had for that was X equals P plus Q divided by 2. Negative 3 plus 1 is negative 2. Negative 2 divided by 2 is negative 1. So our axis of symmetry is X equals negative 1. And the vertex, we can find the vertex by plugging in the axis of symmetry. Okay. Our equation was 2 times X plus 3. But instead of X, we're going to plug in negative 1. Negative 1 plus 3. Times X minus 1, negative 1 minus 1. So again, those negative 1s are just plugged in from the X value of the X, or the X value of the vertex, which is the axis of symmetry. All right, so we evaluate this. We got 2 times 2 times negative 2, which is negative 8. So our vertex is the axis of symmetry, negative 1, and the Y value, which we just found, negative 8. Okay. And then domain and range. Domain, all real numbers. Range is going to be, since we have a minimum, that means all of our Y values are going to be bigger than that minimum. It's going to be bigger than negative 8. Okay. All right, then graph it. Graph a vertex, 1, negative 8. Negative 1, negative 8. Just down here. We graph the intercepts, negative 3 and 1. And do we know anything else? Doesn't look like it. So usually you want to graph these with 5 points. So I'm going to find another point. We can find them. We just use the y-intercept. Plug in 0 for X. Didn't ask for the y-intercept. But remember, the y-intercept is A times P times Q. Our A value is 2. Our P value is negative 3. And our Q value was positive 1. So that means our y-intercept is negative 6. So we graph that point. We also knew the axis of symmetry. Okay. Axis of symmetry was -1. So anything we graph, anything we graph on one side of the axis of symmetry can automatically be graphed on the other side. So if we graph the -6, the 0, -6, we could also go on the other side. Mirror it. Alright. 5 points. Graph parabola. Yeah, it's not that bad. Okay. Alright, second one I'm going to run through a little quicker. So this isn't a 40-minute video. It opens down because the A value is negative, which means it's automatically a maximum. The vertex is going to be the max. The X-Intercepts. The X-Intercepts on this one is we have -1/2 times x minus 4 and x minus 8. So our X-Intercepts are going to be 4 and 8. We're going to go ahead and graph those now. Might as well start constructing it. 4 and 8. Alright, well, just looking at that graph, looking at those 2 points I drew, you got 4 and 8. Well, halfway between them is 6. Halfway between them is always going to be the axis of symmetry. So we don't have to use the formula. We can just see it. It's going to be 6. X equals 6 for the axis of symmetry. Now, again, you could have added the two X-intercepts together and divided by 2. Alright, our vertex, we're going to have to plug in the axis of symmetry for. So we're going to plug in 6 into all of our x values. So 6 minus 4 times 6 minus 8. Whoops, not -6. Okay. Get -1/2 times 2 times -2. It's going to give us positive, it's going to be -4, positive 2. So our vertex is going to be the axis of symmetry 6, 2. Which is right here on the graph. Okay. Now we knew that was going to be bigger than the X-intercepts because we knew our parabola opens down, so the vertex has to be the highest point. For the domain and range, domain's all real numbers. The range, I'll do this one in interval notation. Okay. Well, the highest point is 2. The lowest point is going to be infinity, negative infinity. So we'll say negative infinity. That should be a parenthesis, not a bracket. It should be negative infinity to positive 2 with a bracket. As an inequality, that would be y is greater than or equal to, or no, y is less than or equal to positive 2. Okay. All right, and again, we have 3 points here, but we need 5 to make a good graph. Okay. So let's see if our let's see if our y-intercept is on the graph. It might be off. It might be too big. Okay. So our y-intercept should be a times p times q. A is -1/2, P is 4, Q is 8. It's going to give us a Y value or Y-intercept of -16. Okay. So my graph only goes up to -12, so it's going to be off the graph. You could probably guess it's going to be around here. But I don't like guessing. So I'm just going to pick another point. I'm going to pick a point that's closer to the points that we know. For example, you plug in 2 or you can plug in 3. I'm going to plug in 3. Okay. So I'm going to find f of 3. So I'm just going to plug in 3 for all the x values. 3 minus 4 and 3 minus 8. Simplify that, -1/2 3 minus 4 is negative 1. 3 minus 8 is negative 5. Okay. So I got 3 negatives here. So it's going to be negative 5 halves, negative 2.5. So I go over 3, down 2.5, which puts us right here. Remember, you could always flip that over. Okay, because it's symmetric. All right, so I have 5 points. They're not 5 great points, but they're 5 points. I don't need anything else, so I'm going to go ahead and graph this. Okay. Again, the bare minimum is always 5 points. That's terrible. Okay. All right, we skipped 3 and 4. Okay. 3 and 4 I'm going to do the first parts at least, because they are good problems if you want to look at these. These were in standard form. So they gave it to you in unfactored form. So you'd have to factor it. Again, remember factoring. Always check for your GCF first, greatest common factor. We do have a greatest common factor here. We have a greatest common factor of 3, x, which was going to leave behind x plus 4. Okay. Now this one, I might as well do the whole, I won't graph it, but I'll do all the info. This one's going to open down. The a value is the same a value in factored and unfactored form. It's positive 3. It opens up, which means there's going to be a minimum. Vertex is going to be the lowest point. The y-intercept you can find from factored form or from standard form. The y-intercept in standard form, since this was written in standard form, is always a c value, and there is no c value. So it means the y-intercept is 0. The axis of symmetry, find the axis of symmetry from vertex or from standard form or from factored form. The axis of symmetry is the opposite of b over 2a. Okay. And in this particular problem, the a value is 3, the b value is 12, and the c value is 0. So the opposite of b would be negative 12 over 2 times the a value, which is 3. Negative 12 over 6 is negative 2. Which means automatically the vertex is at negative 2, comma something. So we'd have to plug in negative 2 in for x. Again, you can do that from factored form or from vertex form. Do standard, or not vertex form. We haven't done vertex form yet. Factored form or standard form. Okay. So I'll plug it into the standard form. That's negative 4. That's 4. 12 plus negative 24. 12 plus negative 24 is negative 12. Domain, all real numbers. Range, since it opens up and has a minimum, means all the values are going to be bigger than the y value of the vertex, which are negative 12. Okay. Now it doesn't ask for the x-intercepts here, but we could find them. The x-intercepts we have to do from factored form. So the x-intercepts, we don't really have two binomial factors like we normally do. We have just an x and we have an x plus 4. One of those x-intercepts is going to be negative 4. The other one's just 0. Okay? Because it's x by itself. There's nothing else being added or subtracted to it. It's not a binomial. It's x plus 0 or x minus 0. And we also know that because the y-intercept is 0, which means that the x-intercept is also automatically 0. Graph those. Graph the vertex way down here. You would need another point, so you could plug in 1, for example. It'd be, or negative 1, rather. Negative 1 squared is 1, times 3 is 3. Minus 12 is negative 9. We're going to talk some graphing techniques in the next lesson. There it is. Alright, so that one is some standard form. That wasn't required for the homework, but it is good information. Alright, again, I'm going to run through this kind of quick to make it not too long of a video. 5 and 6. The y-intercept, this one is in factored form again. It's x minus 4, x plus 4, difference of squares, if you remember that pattern. We got an a value of -1. We got a p value of 4. And we got a q value of -4. So our y-intercept is going to be a times p times q, which is positive 16. Graph that. The axis of symmetry, p plus q divided by 0. Or, not 0. P plus q divided by 2. Been doing too many of these videos. P plus q, 4 plus -2. Or 4 plus -4 divided by 2. 4 plus -4 is 0. 0 divided by 2 is 0. So the axis of symmetry is x equals 0, which is just the y-axis. So our vertex is already known. Our vertex is 0, the x-axis symmetry, x value of vertex. And since the axis of symmetry only crosses the parabola at the vertex, that means our vertex is going to be 0, 16. Okay. Now it didn't ask for the x-intercepts, but we know the x-intercepts. We already wrote them down. Those are the p and the q values. So we're going to have positive 4 and -4 for intercepts. And then again, you would need one more point. I would pick, plug in 1 or plug in 2 or plug in 3 and then flip it over. If you plug in, let's plug in 2. Oops. If you plug in 2, you got negative x minus 4. 2 minus 4 is -2. And then 2 plus 4 is 6. Okay. So f of 2 equals 12, which means that's the point 2, 12. Graph it, and then flip it. That's getting worse at these. All right, and then 6. So if you're skipping around, this is number 6. 6 isn't written in factored form. Good. True factored form is x minus 3 and x minus 3, a binomial times a binomial. So we have our a value of 1, our p value of 3, and our q value of 3 as well. So this one's kind of special. All the other ones had 2 x-intercepts. This one's only going to have 1 x-intercept. It's going to have an x-intercept at 3 and 3. So this is something we talk about more in Algebra 2. It's called a multiplicity. But that means our vertex, if we only have 1 x-intercept, it means the vertex is on the x-axis. Okay. And if our vertex is on the x-axis, that means the vertex is the axis of symmetry. The vertex is going through, the axis of symmetry always goes through the vertex. So that value has to be the axis of symmetry. Okay. And again, that means that the vertex has to be there. That's it. It's going to be 3, 0 sitting on the x-axis. So we don't know we don't, this one doesn't have almost any information. You'd have to plug in more values to get 5. We only have 1. We can find the y-intercept. I guess I skipped that up here. The y-intercept, a times p times q, 1 times 3 times 3, which is 9. And then you can flip that over. 1, 2, 3 to the left, 1, 2, 3 to the right. Okay. And then if you plug in one more point, for example, I plugged in 2 and I got 1 out. You could also plug in 1, and you're going to get 4 out. Okay, so that's just plugging values in. We got 6 points, 7 points now. Graph your parabola. Okay. All right, 7 and 9. 7 and 9 gave you the graph. You had to find the equation in factored form. Okay. A lot of information here. Find the zeros, plug in the zeros in the factored form. Use the y-intercept to find the value of A. Find the Axis of Symmetry, find the vertex. All right. So this graph here, the important features of the graph are always going to be the intercepts. The X-intercepts, the y-intercept, and the vertex. Okay. The X-intercepts are going to be your P's and your Q's. Okay. So we got one X-intercept at -2. So the first one's going to be X minus -2. Now, usually we would write that as x plus 2, but I'm just going to leave it as is for now. The second intercept is at 3, so x minus 3. Finding the a value is a little tricky because you have to find, I mean, we know what the y-intercept is. Y-intercept is 6. We can see that on the graph. But finding the a value, the number in front, is a little different. We know that the y-intercept is a times p times q. The y-intercept is a times p times q. But we know p and q. We know p is -6 or -2. And we know q is 3. So we could solve for a now. It's going to be 6 equals -6 times a. Divide by -6. So your a value, 6 divided by -6 is -1. It goes out front. The axis of symmetry. Axis of symmetry is halfway between these 2 points. So if you want the axis of symmetry, you can kind of guess it's going to be probably going to be 1/2. Okay. Let's find out for sure. We'd have to do -2 plus 3. P plus Q divided by 2. -2 plus 3 is 1. 1 over 2 is 1/2. All right. So axis of symmetry is x equals 1/2. Finally, the vertex. The vertex is a little harder to see. Okay, we know it's a little above 6, but we can't see it. It's below 7. It's probably 6 1/4. But we can find out for sure because we now know what the equation is. So to find the vertex, we're just going to plug in 1/2 into the equation. So it's going to be -1 times 1/2 minus 2 minus -2. So I might as well now write that as a plus. And then 1/2 minus 3. Okay. So it's going to be -2.5 times -2.5. So 2.5 times 2.5 is just what we expected, 6.25. So our vertex is going to be the ordered pair negative 1/2, 6.25. All right. Real quick on number 9 to wrap this up. We got X-Intercepts at -5 and -1. Our Y-intercept is... Oh, is that not perfect? Okay. I'm going to go ahead and say we'll skip this one. We could do it, but it's hard to tell what the Y-intercept is. I don't know if it's supposed to be 2 or if it's bigger than 2. So we'll just cut out number 9. You can still find the axis of symmetry. Probably shouldn't put an X on that. Vertex is obvious on this one. Vertex is -3 to -2. Which means the axis of symmetry is automatically X equals -3. So actually I take back that X. We could find this without the intercept. We know that the axis of symmetry formula, so we could use that to find A. The axis of symmetry formula is that the axis of symmetry is equal to -B over 2A. Oh, but I guess we don't know B. Okay. So scratch that. I mean, I know what the answer is. The A value is 1/2. We're going to talk about more why I know that's 1/2 tomorrow in the next lesson. But you don't have to worry about that on any of the mini quizzes. All right, so that was the homework. Put a star on this. I'll put the PDF on